also see me. Need to stay a little bit far away, otherwise people will not see my head. Yes. Hi, everybody. Thank you for joining us today. Welcome. Welcome, of course, all to the newcomers, the people that we see for the first time, but also, of course, welcome back if you have been with us at the workshop before. So especially for the newcomers, of course, who are we? We are the PyLadies Amsterdam. PyLadies is a global organization affiliated with the Python Foundation. Excellent. We have confirmed sound, so that's good. And we are the Amsterdam chapter of the PyLadies, and our goal is basically to enable women and other underrepresented groups in the tech field to have a voice, to share their knowledge, to balance the conversation in a otherwise quite male-dominated field. That's our goal. That's why we're here today at the JetBrains office. Quite exciting. It's quite a nice office, isn't it? Thank you for having us, of course. And yeah, would you like to say some words to introduction? Probably nice to do that here because then people can see you. Otherwise, you will be a disembodied voice.
Yeah, hi everyone. My name is Evgenia. I'm from the PyCharm marketing team. It's very nice to see you here. We are really happy to partner with PyLadies. And on behalf of JetBrains and PyCharm team, I hope you enjoyed this evening. I wish you a very lovely evening. And yeah, let's have fun.
Thank you. Wonderful. Hey, then thanks again for joining. And then I will give it to you.
Yes, thank you. Let's see, let me share my screen. Perfect. Yeah, thanks for the intro, Julia, and welcome everybody to our Dapr in Action from Core Concepts to AI Agents workshop. Yeah, quick thank you from Mark and I as well for joining, and to PyLadies for creating this amazing community and helping us organize the workshop, and to JetBrains for hosting us. Maybe before we kick off, quick introduction from me and Mark. So I'm Dana. I'm a community manager at Dapr for, yeah, it's been a few months, I think now. Other than that, I'm a platform engineer at Ahold Delhaize. Work on the data platform team there. And I really enjoy improving developer experience, automating things. So that's the cross-section for me with what I do and Dapr. And yeah, it's been a lot of fun. It's a really nice project, and we are happy to introduce you to the new addition to Dapr, which is AI Agents. I'm gonna pass the mic now to Mark for a quick intro as well. Yes.
Right. Hi everyone. I'm Mark Duiker, also one of the Dapr community managers. I've been doing this for 2.5 years now. 2.5 years ago, I also started working at Digrid, and Digrid is a company founded by the co-creators of Dapr open source. So we maintain Dapr, but also create some commercial tools on top of Dapr. But yeah, today we're really talking about only about open source and nothing commercial, because the open source part is really amazing. And yeah, that's mostly it. Let's continue, I guess.
Yes.
Yeah, first you.
Switcheroo, yeah. Maybe just a quick intro to the agenda and the goals for today. So we have a few slides, but we aim to keep the intro together with the setup for the workshop maximum to 20-30 minutes. So you have like an hour to get your hands dirty and try out a few things. For the introductory part of the workshop, we want to introduce you quickly to Dapr and show you how you can create an agent with Dapr Agents. Then, of course, agents use LLMs and tools, so we will introduce you to both. If some of these concepts are still a bit new for you, don't worry, we'll go through them in detail in the slides later on. To create the agent, we will use the React pattern. We will go in details on what this is later. And then we have a more advanced part of the workshop, which is creating a multi-agent workflow. We'll see if we have time for this as well at the end. But if we don't worry, we have a README, we have all the information there, and yeah, you can also do it self-paced at home. And at the end of the slides, we have links to our community channels. So if you get stuck and you have some questions or you want to engage with the community, you can join and we'll help you out. So yeah, that's the agenda. And yeah, next, Mark will guide us quickly through the Dapr project and Dapr Agents, and then we will go ahead with the workshop. So yeah, passing the mic one more time to Mark.
And I will introduce it in a second. So, like, side note for those who are here in person, as soon as we get to this hands-on part, on the corner there is here. So basically here there is a QR code and also login and password for the Wi-Fi, because if you want to do the workshop, you need to connect to it. So I think it would be best if you do it now. Just please scan so we have this, or make a picture or scan to access to the internet, and then we can continue. In order not to interrupt the flow.
Yeah, very
Go.
Okay.
You go. All right. Okay, I'll give you like a super short introduction to Dapr, which doesn't do it justice because Dapr is like a huge project, so it will take like many hours to explain it, but very brief summary. So Dapr is used to actually speed up the development of distributed applications or microservices, if you want to call it. It's really it's not a framework, it's not a library, but it's a runtime. So Dapr is usually run in a separate process next to your own application, usually in a sidecar. And you will run it as a sidecar locally, but for the workshop 1 to 3, you're actually not using Dapr as sidecar, but you're just using Dapr Agents as a library. So Dapr, the open source project, has been around for 5.5 years now, and it got into the CNCF, the Cloud Native Computing Foundation, I think 2.5 years ago. And since last November, it's a graduated project within CNCF, which is a really big thing in the cloud native space. So yeah, a lot of big organizations are really successful with Dapr. So yeah, it's quite a mature project now. Well, like I mentioned, it speeds up the application development, and it does that by providing lots of different APIs for pub/sub messaging, for service information, but also for lots of state management. So if you want to store some key value pairs in a state store, Dapr provides APIs for that. And Dapr has like a built-in workflow engine, so you can write your workflows in code in different languages, also Python, because Dapr Agents is also built on top of that. So it really gives you a big tool belt for developers to quickly build microservices. So the goals of Dapr, well, like I mentioned, it provides a lot of APIs which you can use to quickly build services. It also comes with all kinds of best practices and standards as well. So for instance, for if you do pub/sub messaging, the messages are wrapped in cloud events, which is another open source standard for pub/sub events. There's also built-in retry policies in Dapr, which you can still configure and override. So there's a lot of things that you don't have to write yourself, but Dapr takes care for that. It's also extensible and pluggable, because, well, yeah, I mentioned it a couple of times, you can do pub/sub messaging with Dapr, but Dapr itself is not a message broker, but you can configure Dapr to use like any message broker out there. So if you run it locally, you can use like Redis in a local container, but you can also use an Azure service or an AWS service or a Google service, and all of your application code stays the same, because Dapr provides an abstraction layer, and you can configure it to use any other underlying infrastructure services. You can use any language or framework because Dapr is language agnostic, because it runs in a sidecar and it provides some APIs that you can use from your application. Also platform agnostic, because it typically runs on Kubernetes, and people run Kubernetes everywhere. And like I mentioned, it's community driven, an open source project, also vendor neutral. And there are some players who do a large part of the contributions to Dapr, and Dapr is one of them. And also Microsoft was a big maintainer as well. But these days, a lot of other companies like Intel is also doing a lot of work for it. Also AWS is helping out as well. So a lot of different organizations are also building Dapr. Dapr Agents is really the really super new. I think it's only a couple of months old. I think it's very new, because of course everyone is doing AI. So Dapr thought, okay, we also need to do something AI related. But yeah, it's a really cool library, and well, I'm gonna hand it back over to you, Dana, to introduce Dapr Agents to everyone.
Yeah. So Dapr Agents is quite new, as Mark said, a few months old, and it's built on top of the Dapr runtime, and it enables you to build AI agent systems at scale. So it abstracts a lot of the complexities for you, so you can get started easier. It's Kubernetes native, so it also simplifies the deployment, and you can easily build from single agent system to multi-agent systems, as we're going to see later. This is a very high overview picture of what an agent is, just as a quick introduction, and then we're going to zoom in a bit and see how Dapr implements it in the background. So here in the core, we see, this diagram represents an agent, and you as the user provide an input to it. So the agent essentially is an LLM that acts as the brain for the agent, and the agent uses it to understand the user input, then plan what it needs to do, and then finally execute an action. So the LLM that the agent uses, it's great for understanding natural language, but it has some limitations. So to create an actual agent, we need to expand its capabilities with a few things. One of them is tools, and this is essentially just a function. So it's just a Python function that the agent can access. And the nice thing is it can choose autonomously which tool it needs to use without input from the user. So it does some analysis in the background, and then it chooses the suitable tool for the task at hand, and then it executes it. Then you can also provide memory to the agent, and essentially this can be one of two things. It can keep chat history, so it can keep context of what happened in the past and adjust its action and the way it reaches to certain conclusions based on it. But you can also give it access to some specific data. So for example, you're working in a specific domain, maybe medicine. Let's say I saw an interesting presentation recently. They were doing an analysis on bias in research papers. So they gave access to their agents to a database of specific medical papers that were labeled. So this kind of things can improve how the LLM operates. Other than that, you can have the agent delegate tasks to other agents that are maybe more suitable for the task at hand and read observations from the environment. Agents are really useful when you have complex flows that you cannot simply specify in an easy if-else. So you want something that needs maybe minimal human input, and it has flexibility to choose what it's going to do next. Next, let's zoom in on how Dapr implements Dapr agents. So essentially, as I mentioned, you have the LLM that acts as a brain. It receives a prompt from the user, and then it uses it to understand what the user requests. Then Dapr implements multiple reasoning flows. Today, we're going to specifically see React, and this allows it to plan what's the best way to execute the task in hand. So plan what it needs to do and then take an action. If it concludes that it needs to call a certain tool, and maybe this is actually a good moment to mention when tools are useful. Tools are useful when you need an information from the outside world. So LLMs are really good at, as I mentioned, natural language processing. So this can be text generation, text summarization, translation. generating ideas, brainstorming. But then if you ask for current up-to-date information, that's not always possible. I think ChatGPT, if you guys use it now, has the option to fetch information, like if you ask what's the weather like, since I think February this year, but that's because it acts as an agent. So it's not just a simple LLM. But most open source free models don't have this capability. So you need to extend it with a tool to get this information via an API. So the tools are needed for things that you need factual real-time information. So think weather, stock prices, flight prices, flight status, etc. And yeah, another risk here is the LLM can hallucinate. So if you really, then you are safer implementing a tool and calling an API. But then essentially, let's say you prompt a agent and then it decides that it needs to call a tool, then it's going to do it automatically without you having to hard code it. It's going to fetch this information and then provide it back as an observation to the LLM. Then the LLM is going to go again to the reasoning loop, see if it has all the information it needs, and then provide a response back to the user. So we mentioned here that we have a reasoning flow. So in the workshop specifically, we're going to see the React pattern. And yeah, this is quite a recent pattern, I think like also just maybe 2-3 years old. But it essentially allows the LLM to break down the task at hand in smaller chunks. So it thinks ahead which step it needs to take, observes like the output, and then decides which tool it needs to call, if it needs to call a tool. So then basically it gives you an overview as to why it's doing something, like it gives you the background and the analysis, and then provides an observation back, and then finally provides the final answer. Yeah, it's nice when you want to get like a detailed explanation of the reasoning, but then because it goes through this cyclical process of thinking, providing observation, and then thinking about the action before giving the final response, it is more expensive. It uses a bit more tokens than just using a regular flow, but it's good for traceability. So yeah, this was the last bit of theory you will need for the workshop. So yeah, I'm gonna next go ahead and show you what we are going to build. So in the introductory workshop, we're going to build a simple productivity bot. And the idea is, yeah, to have a bot that helps you collect daily news, summarize them for you, and provide some explanation and insights. Then we can extend it with few functions and tools. For example, we can also ask it to fetch the stock prices, and then maybe see if this company that we are fetching the stocks for is mentioned in the news, and provide some sentiment around it. So yeah, if you're feeling like the news are crazy and it's hard to keep up, like in the recent times, then maybe this is something that can help with that. The tech stack we're going to use is Dapr Agents, of course. So we're going to use it as a framework to build our agent. For the LLM, we're going to use one of the Hugging Face models. So we're going to use one of the free models. We will provide you with tokens, but yeah, this is just free. So if you want to try it out again at home, I can show you how you can generate your own API key later. And then for the functions or the tools that we are going to build for the agents, we're going to use the currents API, which is essentially fetching the daily news from a specific region, and the Yahoo Stock Market API to fetch the stock prices for a certain company. Yeah, maybe let's get started with the setup then. I'll give you like a few minutes to maybe go through this, but there is one of two. You can use Jupyter Lab. You need to clone the repo, or you can do Google Colab, and then that's completely operating system agnostic. When you go to the README, you're going to see there is a link to a private bin. This is the password. And inside there is a bunch of API keys that you can use for the workshop. I'm gonna give you like maybe a minute to scan things, and then we can go through it together. Yeah. And then I'll show for the people on the stream how to set it up, but I'm just going to give everybody a few minutes to get started then. Yeah.
Like, what is like Dapr agent? Is that already an agent tool, or is it kind of like a framework where you can actually implement the logics to make it an agent?
Yeah, it's a framework that simplifies for you how you can create an agent. You're going to see it practically, but it's first of all provides a wrapper around many of the very popular commercial LLM APIs, and then it already abstracts quite a lot of the logic for implementing the agent itself. So you just provide the pattern it wants to use, an LLM and instructions, and then essentially you can create a agent. So it has ready-to-use functions you can use to create your own instance.
Just to understand the philosophy from Dapr's side, like,
Mhm.
Dapr, to my understanding, was kind of like another setup or a framework to make already existing service maybe have some additional features on top of it, right? Like it's like a sidecar which will go and
Mhm.
like, make your service a bit more better and maybe a bit more easier to develop, like Mark showed. I'm not able to fully understand like how, like where Dapr agents come in. Like, is it also kind of like a sidecar?
Yeah, the question is how does it build more precisely on top of Dapr? Like if it also runs as a sidecar. For the introductory example, no, it's just a Python library that we're going to use. So for there, you don't need the sidecar. You just need to install the Python library, and that's sufficient for now, just to have the agent. For the deployment part, like if we get that far, we are going to share a bit more details on like how it incorporates further with Dapr, but that's maybe a bit for later on, just to keep the two things separate for now. But the advanced part of the workshop covers this. Yeah.
Thanks.
All right, I'm going to minimize this and quickly guide you through the process. So for Jupyter Lab, I have the repo cloned over here. So I will just navigate to the root, and then following the README, I can install the dependencies. I already ran this, but essentially you just need to either use UV or install the requirements using pip. So that's up to you. And then after that, I will navigate to introductory workshop and then helper secrets. And then for this, you will need to access this private bin. So I'm going to open it here, copy the password. Oh, a bit tricky. Where is it? I lost it. There it is. Yeah, so we have a bunch of Hugging Face API keys here. Just pick at random. Just so we don't hit the limit. So 1 to 10, and then also you need to set the current API key. Also pick randomly, like from the tree, and set it in the helper secret. And then after that, you can navigate to workshop and then start the notebook, and then go from there. Let's give it a second. Okay. Then you can open number 1. And then there is some specific instructions over here. If you're using Jupyter Notebook, you need to import the secrets, for example. That's on the setup with Jupyter Notebooks. If you're using Google Colab, I have it open over here. Then go to GitHub over here, copy the URL, and paste it. And then you can open the first notebook, and then there is specific instructions over here you need to follow. So you need to install some of the dependencies manually, and then you need to set up the secrets. For that, you need to click on this key over here, and then add the Hugging Face token and the current API token. And yeah, import them, and then we are ready to start. So I'm going to give you a few minutes, maybe let's say until 35, and then I'm going to go around and see if there is any questions. Also, if there is any questions in the chat, we'll answer them. So yeah, I'm going to mute myself then maybe for a few minutes, and we come back at 35. issues. Okay, everybody's set up. So I'm going to guide you through the exercises and give you maybe a bit of time to try and do them yourselves. And then I'm going to show you the solutions at the end. I got some questions about the API key. If someone wants to try them at home, I'm going to show at the end how you can create the token yourself. So yeah, we have the environment variable set, and then from Dapr Agents, we can import the Hugging Face chat client. So this is a wrapper on the Hugging Face API, and it allows us to in a very simple way, call a specific model from Hugging Face and use it to, generate some outputs. In this case, we're using the Microsoft Phi 3 model, but you can use whatever. If whatever is supported on Hugging Face, you can use this model over here. So over here, I'm creating an instance of the client with the API key and the name of the model, and then I'm just providing a prompt for the LLM, which in this case is what is the impact of AI on the news, and then I'm limiting the output to a single sentence because I just want to restrict the amount of tokens we're using. This is nice for like when you're prototyping because you don't want to use up your tokens really quickly. So over here is just so you guys get a bit more familiar with the output that the client provides. So you can play around a bit, like see what the different parameters are. And over here at the end, it also shows you the output that it's giving you. It also shows you how many tokens it consumed to generate this output for you. So I mentioned briefly during the presentation that LLMs are great for generating text. But then if you ask for a specific current information, like get me the news today, then it will say, hey, I'm sorry, but I don't have real-time information. So the idea later is to allow the LLM to be able to access current information. So this is the first exercise for you. We're going to try a simple prompt engineering. There is few prompts you can write here. So for example, you can fill in the text here to try to get the LLM to return a list of things, a single word, ask for a creative story. Just to get familiar a bit with the basics of prompt engineering. Then you can play a bit with the parameters. For example, you can set the temperature. This basically tells the model how deterministic it should be. And finally, there is a small example on Prompty. Prompty is a tool you can use to give extra context to the model, and it integrates really easily with the Dapr Agents library. Play a bit with the information we are giving in the prompt to see how the personality of the agent changes when you change the description or you tell the agent how to act. You can, for example, tell it to be more serious or more funny, answer more verbosely or more shortly. So this is just to get a bit familiar with like the wrapper around and see the structure of the output. And then next we're going to move into creating the tools and then finally the agents. But let's get started with this. So maybe then we do 20 minutes, 10, 20 minutes, and then we go to the next notebook. So I'm going to mute myself again, walk around, and then if there's any questions in the chat, we can also answer them. All right, I'm going to quickly show you the solutions before we move on to the next one. Let me see. It's here. So we had few people that got different responses to the same prompt. Maybe it's good to mention now that, yeah, by default, LLMs are non-deterministic. So for the same input, you can get different output. So for some people, it hallucinated and it gave the daily news, even though it was not really the daily news, but something from like a few years back. But yeah, let's go maybe quickly one more time. So this one we saw, this is just how you create an instance of the client. And then over here, we got familiar with the content of the output. So it shows you like the output, what model we use, how many tokens we consumed. So if you want to track that. This was the example for the current information. And then this is some examples on, yeah, some basic prompt engineering to try and get the LLM to return a specific output. So for example, yeah, list of 5 random hobbies, short stories, and what is one word that describe the feeling of finishing a long project. This is an example on how you can tweak the temperature. So this is this tells the LLM how deterministic or not it should be. And then we had a nice question about how to see the signature. That was Shift and
Shift tab. Opens
Shift
the
tab.
contextual
Yeah.
handling. Very handy.
Yes. And then finally, the promptee was, yeah, just to provide an extra context and personality for the agent. All right. You can find the solutions over here in these folders. If you want to take a look at them later, you can, yeah, look at them yourself. Next, let's move to the second part of the exercise, and this will be about preparing the functions that we're going to use to create the tools later on, and essentially creating our first agent. That's going to be the wrap up in the next notebook. So
Just a quick thing.
Yeah.
There was a question. It's a little bit like for beginner where you were just choosing, deciding which model to use. The
Mhm.
question was, can you use Grok with Dapr?
Oh, I'm not sure. I don't think so.
I haven't seen it.
No, I don't think so.
No.
But it's open source, so if someone is up for adding it, yeah, we're open to contributions. But yeah, I don't think so.
Okay, thanks. That's
Yeah.
online question.
Yeah.
That's why we asked it. Thank you.
Yeah, all right. So the second notebook, we will create the functions that we will use as tools, and then in the end we will just put the tools together with the agent and then see how it all works together. This is a small summary of some of the things I already mentioned in the presentation. So if you want to like just follow the notebook later on and refresh some of the concepts, it's all in one place. So unfortunately, you will have to rerun this. It doesn't transfer across notebooks, so just the secrets will be there. You just need to re-execute the cells. Here we have some very simple Python functions that just implement a simple API call to, in this case, fetch the current news. So that's what the second API key that we provided is used. So you can, yeah, do this call and then see the output. Your exercise would be to implement something similar using the Yahoo API. So very simple function that fetches the current stock prices for a company, in this case, NVIDIA. If you get stuck, feel free to take a look at the solution, because the goal here is not really like, hey, do you know how to make an API call, but just to understand that in the end, the tool is just a simple function that does an API call. So if you don't want to dig too deep into this, feel free to just take a look at the solution. And then finally, I want to show that you can also use an LLM. Even though it's the brain of the agent, it can also be used as a tool. So we want to provide the input from the news we fetched and then ask it to summarize. We're doing it here manually, but then later on the agent will know to do this automatically itself. That provide based on the prompt from the user, it will understand which tools to call in which order, and we will not have to manually tell it to first call this function, then call this function, and then provide the output. So yeah, this is quite a short notebook. It's just so we get everything prepared for the final part, which is plugging in these three tools into the agent and then seeing how it knows automatically using its reasoning loops to pick the right tools for the action it wants to take and then providing a response. So maybe like 10-15 minutes. And then we go to the last
This one
bit.
can take a bit long.
Oh, okay, then 50.
Okay, 10 to 15 minutes. We'll see how it goes. Yeah.
Yeah. So the following the following agent attributes explicitly set for the user, but not considered by the prompt to play, name or instructions. So to me, it's in this map of somewhere.
It's just about building a function.
Just like standard.
Yeah. Okay, I'm just gonna quickly show you the solution and then we can move to the final part. So the value of the, oops, let me just zoom in quickly, sorry about that. The value is not so important, like what you return here. All I wanted for you guys to know is that a function is, the tool is just a function and nothing else, as we're gonna like see in the next exercise. So the implementation is not super important. So that's why I didn't want to also spend too much time on this exercise. But yeah, just for you to see, yeah, we just implement this Python function and then we can later use it in the agent and put everything together. And that's essentially what the last part of the introductory workshop is. We will combine everything we built so far and create an agent. So we will have to, unfortunately, well, it's already there, like copy some of the code, but we have it here. So we have our function for the news, and you can see I added the tool decorator. So this is very neat. This is all you need to do to convert a function to a tool for Dapr Agents. So this gives context to the agent that this is one of the available tools it can use us, and it chooses autonomously, like which tool to call. So you don't have to tell it in any way. Here is the LLM to summarize the news. And then you see I did one more thing over here. I provided a pedantic model. This is a good practice because it helps you, standardize and provide some structure to the input and output you're providing to the tool. And the description is another very important thing because this is actually something that the Dapr agent uses in the background. So the more precise and clear the description is, the better the agent will know which tool to use for a specific action. So you can try removing it and you will see it's going to fail. So for this exercise, yeah, it should be pretty simple. You need to provide the pedantic model yourself and also convert this function into a tool. So just using the decorator. And then finally, we can build the React agent. The React agent, as I mentioned, is one of the reasoning patterns you can use. Dapr implements many, but for this example, we will use this one. So this is the structure of an agent in Dapr. You have the type of agent you want to build. You provide the name, you provide its role and instructions, and then over here you need to provide the list of tools, which is nothing else than the list of functions, and then you can call it and then see the way it navigates the task you're giving it. So it should loop through all the tools and choose the one that's like right for the action, and then call it and then provide you an output. So that's the goal. I have some sample output over here. So you see it provides quite a detailed explanation on the steps it's taking because it's a React agent, but you'll see it yourself. So 10-15 minutes. Unfortunately, we will not have time for the advanced part of the workshop, but I'll give you maybe a quick guide on it on the slides, and then you can do it self-paced at home. It's a fun one. So okay, let's begin. I'm going to mute myself again, but I'll circle back if there is any questions in the chat, maybe. Can go from there. Okay, I see some of you are still like almost done, but unfortunately we're running out of time. So I'm just going to quickly guide you through the solution, and then we can spend a few more minutes after to get everything wrapped up. But yeah, creating the agent with the tools, it's quite easy. All you need to do is provide a list over here. And then the agent loops autonomously through the tools and decides what's the best tool for the specific action. So in this case, I ask it to fetch me the daily news and summarize them. So then it understands it needs to call the get latest news function, and it shows you how it's calling it with which arguments, which is really nice for debugging. Then it shows you what it fetches, and then it summarizes it for you. So without me telling it, hey, first call this and then call this, it decides on this complex multi-step solution, and then yeah, provides the output for you. Yeah, there were a few exercises here to show how you can get it to call different tools. So in this case, the stock prices tool, and then there is another even try and chain the commands and get it to call both, and it does all of that on its own autonomously. This is just an example on like that it preserves chat history, so it has a memory attached to it. It remembers the conversation you had over multiple interactions, and you can clear it and start fresh. So if you feel like it's keeping some things in the context that are maybe no longer relevant and you want a fresh start, you can easily reset it and then start over. And then call it again, just to see like if it provides a different output. So yeah, this was it for the introductory workshop. Unfortunately, we don't have time for the advanced one, but I will quickly guide you through the slides, and then you can try it self-paced at home. The slides are linked here in the QR code, so it gives you the instructions on which folder to navigate and how to set it up. This one you will have to run locally, but it doesn't require a lot of extra steps. You just need Docker and the Dapr CLI. And then this exercise really exposes all the components of Dapr. So the idea is to create a multi-agent solution that uses the message broker from Dapr. So you as a user would provide the prompt. In this case, we use Lord of the Rings characters as separate agents. So the shared goal these agents have is to get to murder, and that's the user prompt. And then when you run this exercise, you can see essentially all the components, how it picks up which agent to call, and then the agents will call each other and communicate. So it's really nice exercise to see the different components, like the memory, the orchestrator, and how PubSub works in Dapr. There is a README provided. It has quite a lot of context, so you can go through it. And yeah, if there's any questions, you can join our community channels using this QR code. So Mark and I are, for example, in Discord and quite active there. So if you're stuck at any point, feel free to reach out there. Yeah, and maybe one final note, there's also an optional exercise part to the multi-agent workflow. You can try and add your own agent, so extra characters as its own separate agents. So finally, we also give a community supporter badge that you can showcase on GitHub. So if you scan this QR code, it will guide you to Holopin, and you can claim your own badge. So yeah, that's all for today. Thank you for joining, and I hope this was useful for you. And finally, thank you to Una and Julia. Maybe want to yeah.
So, like, time flies, but that was really fun. Like, I think we learned a lot of interesting stuff about how to use agents, and specifically how to use agents with Dapr, which I think is something that will be very useful in the months and years to come. And yeah, I think Dapr will be a very valuable addition to any toolbox there. Again, thank you all for joining. After this workshop, we will have some additional time now for networking, some more drinks together, all that sort of stuff. Yeah, but I don't think I have anything in particular else to share, except maybe the next workshop that Una is going to tell you something about.
Yeah. So we already have a date for the next workshop. It will be fully online, so you can join from the vicinity of your home, or like the staying at home and joining workshop. So we just published it a couple of less than an hour ago. So the date is known. It's 26th of June, and the topic is scale down, optimize AI prompts to reduce verbosity and carbon footprint. So the creator of the library Scale Down will begin a workshop. It's a really terrific library. She's joining us from Berlin. That's why, hence, the online part of the workshop. And basically, through the whole step by step, you're going to go and see first how to optimize your prompts. What are the first steps to do? What are the low-hanging fruits? What's already implemented? And then go in depth further, learning how to work with specific templates, again, to set up specific prompts optimization for working with different LLMs. And after that, also nice, I would say, bonus, also measuring your carbon footprint. So, which is really, really nice. And this is fully online. And I also going to announce the next event as well. So the 15th of July, that would be in-person event. Maybe hybrid, and this would be a little bit unusual event for us. It would be talks. Usually we do workshops, but once per year, once per 2 years, we do, let's say, talks. So I couldn't say exact the name. We're also going to do it as a very interesting community. I couldn't reveal the name of the community yet, but what to expect, it would be really, really interesting conversation about usage of generative AI, other variations of AI for game industry. And while saying game industry, I'm talking about the real game industry, which design games where still a tiny part could be specified in Python. So yeah, that's what's cooking right now for you. So I think that's conclude our online part. So we're gonna stop the stream. Thanks for watching. The timelines would be added to the stream soon. Yeah, and then for us, we are moving, I guess, back up to the networking part, and we still have pizza to finish or take away with us. Yes.
Thank you.